Good day, grade 12s. We are on video number 6, elastic and inelastic collision. Remember that we said the momentum is a vector, is a product of mass and a velocity. The SI units for the momentum is kg meters per second. Then we also did the conservation of linear momentum, where we say in an isolated system the total linear momentum is conserved, meaning that the sum of the momentum before collision is equal to the sum of the momentum after the collision. Okay, now we are on elastic and inelastic collision. We have two types of collisions, that is elastic and inelastic collision. In an elastic collision, the total linear momentum is conserved. So even here, the linear momentum is conserved. And the total kinetic energy is conserved. Meaning that the momentum, the sum of the momentum before collision is equal to the sum of the moment before or after collision. The total kinetic energy is conserved, meaning that the kinetic energy before collision, total kinetic energy before collision is equal to the total kinetic energy after collision. Okay, so in elastic collision, the sum of the momentum initial is equal to the sum of the momentum final, and also the sum of the kinetic energy initial is equal to the sum of the kinetic energy final. Okay, in an inelastic collision, only the momentum that is conserved. So in an elastic collision, the sum of the momentum before collision is equal to the sum of the momentum after collision. The total kinetic energy is not conserved, meaning that the sum of the kinetic energy initially is not equal to the sum of the kinetic energy final. That is in elastic collision. In an elastic collision, no deforming of an object occurs, whereas in the inelastic collisions, deforming of objects occurs. No joining of objects. Objects join and move further as unit. The internal energy of an object remains constant. The internal energy in the system decreases. Okay, so let's take one example from the examples that we did to prove whether the collision was elastic or inelastic, which means if we check whether the collision is elastic or inelastic, we are going to look at the kinetic energy, because in both collisions the momentum is conserved. So if it's not equal to here, not equal to, the EK initial is not equal to the EK final, whereas here the EK initial is equal to the EK final. Let's go to the example, then we check whether the collision is elastic or inelastic. Example number 1, let's just look here. We have object A with 6 meters per second initially, and object B moving with 2 meters per second west. Then we have A after collision 4 meters per second west, and B 3 meters per second east. Now we want to check whether the collision was elastic or inelastic. Remember, For inelastic, the sum of the kinetic energy before collision is not equal to the sum of the kinetic energy after collision. Then elastic, the sum of kinetic energy before collision is equal to the sum of the kinetic energy after the collision, right? Now let's start with initial kinetic energy. So we are going to calculate the sum of EK initial. Then we calculate the sum of EK final, right? So we have the kinetic energy of A initial plus the kinetic energy of B. This is for A, this is for B, right? Remember that the formula for kinetic energy is 1 over 2 mv squared. That is initial in this case, plus the kinetic energy of B, it's 1 over 2 mv squared. That is initial for B. This is initial for A. Now let's substitute. We have the mass in kgs, so it's 1 over 2 times the mass in kgs, which is 4, times the speed to the right, that is positive, to the left, negative, negative, positive. Okay, so the speed is positive for A is 6, so 6 squared, plus 1 over 2 times the mass of B is 8. The initial velocity of B is minus 2 squared. Then let's press the calculator here. So the answer is 888 joules. That is sum of the kinetic energy initial, EK initial. Then we calculate the sum of the kinetic energy final, which means we have EK of A final minus EK or plus EK of B final. So we have 1 over 2 mv squared final A plus 1 over 2 mv final square for B. Now let's substitute. 1 over 2, the mass of A is 4, still 4, mass of A is 4, times the velocity final for B or for A is negative 4, open brackets, then square, plus 1 over 2 times the mass of B is still 8, times the final velocity of B is positive 3, so it's 3 squared. Then let's press the calculator here. So the answer is 68 joules. Now if you can look here, we have 88, then the system loses energy to 68, the energy decreases to what? To 68. Therefore, the collision is inelastic. Since EK or sum of EK initial is not equal to sum of EK final, therefore the collision is inelastic. That is the elastic and inelastic collision. If they said the collision is elastic collision, you know that the collision is elastic when EK, that is EK initial, is equal to EK sum of EK final. Then you work on what is required. For example, they will say calculate the speed if the collision is elastic. So we are going to use this formula. Otherwise, we will always use sum of the momentum initial is equal to sum of the momentum final, unless they said the collision is elastic. So in this case, the collision is inelastic because the sum of the EK initial is not equal to the sum of the EK final. Thank you. Don't forget to subscribe, share, and comment.